Welcome to the Oracle's Rest, a place where stories unfold slowly, where time softens, and where the mind is free to wander. Tonight, we drift out across the vastness of the ocean, far beyond the shoreline, beyond the last lights of coastal cities, beyond the places most humans have ever seen, into waters so immense, so deep, and so ancient that much of them still remain unexplored even today. The ocean covers more than 70% of the Earth's surface. From space, our planet appears blue, largely because of it, an endless shifting world of currents, storms, silence, darkness, and life. And yet, despite how familiar the ocean may seem from beaches and coastlines, human beings have explored only a small fraction of it. In many ways, we know more about the surface of the moon than the deepest parts of our own seas. The deepest known region of the ocean is called the Mariana Trench. Located in the western Pacific Ocean, it descends nearly 7 miles downward. If Mount Everest were placed inside it, the peak would still remain underwater. At such depths, sunlight disappears completely. Pressure becomes immense. The water grows cold, silent, and almost entirely black. Yet life still exists there. Strange drifting creatures, translucent animals, slow-moving fish with glowing bodies. Entire ecosystems surviving in darkness beneath crushing pressure. For most of human history, people could only imagine what existed below the surface. Ancient sailors often feared the open ocean deeply. Without modern navigation tools, crossing large stretches of water could become extremely dangerous. Storms appeared suddenly. Waves rose higher than ships. Fog erased the horizon completely. And once land disappeared from view, sailors entered a world with almost no visible landmarks at all. Only water, sky, wind, and stars at night. Some civilizations believed sea monsters lived beneath the waves. Others imagined gods controlling storms and currents because the ocean itself felt alive, unpredictable, powerful, too large to fully understand. Even today, the open ocean can create this feeling. A person standing alone on a ship surrounded by water in every direction often experiences something unusual. A sense of scale, the realization of how small human beings truly are compared to the planet itself. The Pacific Ocean alone, covers more area than all land on Earth combined. Its distances are almost difficult for the human mind to visualize. Entire mountain ranges exist beneath its surface. Underwater volcanoes erupt silently in darkness. Massive currents move enormous amounts of water across the globe. The ocean is never truly still, even when it appears calm. Waves carry energy across thousands of miles. Deep currents flow slowly beneath the surface. Tides rise and fall through the gravitational pull of the moon. In many ways, the ocean behaves almost like a living system, breathing, circulating, changing constantly over time, and life within the ocean developed long before human beings existed. For billions of years, Earth's oceans shaped the evolution of life itself. The earliest life forms likely emerged in ancient seas. Tiny organisms drifting through warm, primordial waters, long before forests, dinosaurs, or mammals. The ocean came first, and even now, many scientists believe that the deep sea still contains species humanity has never discovered, hidden within darkness beneath miles of water. Some deep ocean creatures produce their own light through bioluminescence, a process where chemical reactions create soft, glowing colors beneath the sea. Blue lights, green flashes, tiny drifting sparks moving through darkness. In the deep ocean, bioluminescence is surprisingly common because where sunlight cannot reach, living creatures create their own illumination instead. Some fish use glowing lures to attract prey. Certain jellyfish pulse softly with blue light. Tiny plankton shimmer like underwater stars when disturbed. At night, near the ocean surface, entire waves can sometimes glow electric blue, as though the sea itself has become filled with starlight. And perhaps because the ocean contains so much mystery, human beings have always been drawn toward it emotionally. Writers, poets, sailors, philosophers, and explorers often describe the ocean almost spiritually. The sea can feel peaceful, but also lonely, beautiful, yet overwhelming. Calm one moment, violent the next. Standing beside the ocean often quiets the mind because its scale is so much larger than ordinary human concerns. Waves continue arriving endlessly, regardless of politics, schedules, cities, or generations. The ocean existed before modern civilization, before human language, before human memory, and it will likely continue long after modern nations eventually disappear into history. Perhaps that is partly why people find the ocean calming. It reminds us of something older, slower, and larger than ourselves. The rhythm of waves especially affects people psychologically. Slow, repetitive motion, constant sound, predictable cycles. Many humans instinctively relax while listening to rainfall, rivers, or ocean waves because natural rhythms calm the nervous system. Even ancient people sleeping near coastlines thousands of years ago likely drifted to sleep, listening to the same sounds still heard today. Water moving gently across sand, wind passing over dark waves, distant gulls fading into the evening sky, moonlight stretching across the sea, and beneath those waves, far below the surface, an entirely different world continues existing silently in darkness. A world most humans will never see. Forests of coral, creatures drifting without sound, mountains hidden beneath miles of water, vast plains deeper than any land canyon, ancient animals moving slowly through blackness where sunlight has never reached. The deeper one travels into the ocean, the stranger life often becomes. Some fish possess enormous eyes, adapted for darkness. Others lose their eyesight entirely. Some animals grow transparent. Others produce red light, invisible to most deep sea creatures. Certain species survive near hydrothermal vents where superheated water emerges from cracks in the ocean floor. These environments can appear almost alien, columns of mineral-rich water rising through darkness. Strange white crabs gathering around vents. Tube worms stretching upward beside volcanic heat. Life surviving in places once thought impossible. And despite centuries of exploration, the ocean still holds countless mysteries. Lost shipwrecks, undiscovered species, ancient geological formations, entire regions barely studied at all. Even now, there are places in the deep sea where almost no human being has ever traveled. Darkness beneath darkness. Silence beneath miles of water. The ancient hidden world of the ocean, continuing quietly beneath the surface of the earth. For thousands of years, the ocean shaped the course of human civilization. Before airplanes, before railroads, before modern highways, the sea connected distant worlds. Wooden ships crossed enormous stretches of water, carrying silk, spices, stories, languages, and ideas between continents. Ancient Polynesian navigators traveled across the Pacific Ocean using stars, currents, wave patterns, and bird behavior to guide them. Without compasses or modern instruments. They cross distances so vast that many modern people would consider them almost impossible. Some memorized the movement of stars across the sky. Others learned to feel subtle changes in ocean swells beneath their boats. The sea itself became a kind of map. And even today, scientists remain amazed by the sophistication of these ancient navigation techniques. The Vikings sailed across cold northern oceans beneath storm-filled skies. Chinese treasure fleets crossed the Indian Ocean centuries before many European explorations. Arab traders moved between Africa, India, and the Middle East through seasonal monsoon winds. Human history has always been deeply connected to water because oceans do not merely separate continents, they connect them. And yet, despite humanity's long relationship with the sea, most of the ocean remains remarkably empty, especially far from coastlines. The open ocean, sometimes called the pelagic zone, can feel almost endless. Days may pass with no land visible anywhere, only shifting water and sky, cloud shadows moving slowly across waves. At night, far from cities, the stars above the ocean become extraordinarily bright. With no artificial lights nearby, the Milky Way sometimes stretches clearly across the sky. And beneath those stars, the ocean itself reflects faint silver moonlight. A ship drifting through darkness, surrounded by nothing but water and sky, can feel strangely dreamlike, almost detached from the rest of the world. The horizon disappears. Distance becomes difficult to judge. Time itself begins feeling softer. Perhaps this is one reason the ocean appears so often in dreams, stories, and philosophy. It creates a feeling of vastness difficult to experience elsewhere. And the ocean is not only vast horizontally, but vertically. The deeper humans descended into the sea, the more unfamiliar the environment became. Sunlight fades surprisingly quickly underwater. Within the first few 100 feet, colors begin disappearing. Red vanishes first, then orange, then yellow. Eventually, the world becomes blue, then darker blue, then black. Below certain depths, the ocean enters what scientists call the midnight zone. No sunlight reaches there at all. The darkness becomes complete. And yet, life still moves through it constantly. Creatures drift slowly beneath invisible currents. Some produce flashes of light. Others remain almost motionless to conserve energy. Food becomes scarce in the deep sea. So many animals evolved unusual survival strategies. The anglerfish, for example, uses a glowing lure extending from its head to attract prey in darkness. Giant squid inhabit deep waters so remote and difficult to access that for centuries people debated whether they truly existed. Some jellyfish appear almost transparent, their bodies pulsing softly with bioluminescent light. And in certain deep regions, marine snow falls continuously through the water. Not frozen snow, but tiny particles drifting downward from above. Bits of plankton, organic matter, dust, and microscopic remains slowly descending from surface waters into the depths, like underwater snowfall in darkness. This constant, slow drifting material becomes an important food source for deep ocean life. The deeper one travels, the quieter the world becomes. Sound behaves differently underwater. In fact, sound can travel much farther through water than through air. Whales use this property to communicate across enormous distances. The songs of certain whales may travel hundreds or even thousands of miles beneath the ocean. Low, haunting calls echoing slowly through darkness. Some whale songs last for hours, patterns repeating gently beneath the sea. For many people, whale sounds feel strangely emotional, almost mournful, ancient, as though the ocean itself is speaking slowly through them. Blue whales, the largest animals known to have ever existed, move silently through these enormous waters. Some grow longer than 30 meters, larger than many dinosaurs. And yet, despite their size, they often move with extraordinary gentleness. A single whale drifting beneath a small boat can completely alter a person's sense of scale. The ocean suddenly feels much larger, deeper, and older, and whales are not the only enormous life forms hidden within the sea. Giant schools of fish move together like living storms. Massive coral reef systems stretch across entire regions. The Great Barrier Reef alone is so large it can be seen from space. Coral itself may appear like rock, but reefs are built slowly over thousands of years by tiny living organisms. These reefs support extraordinary biodiversity. Fish of countless colors, sea turtles, octopuses, sea stars, sharks, crustaceans, entire underwater ecosystems existing in constant motion. Coral reefs are often called the rainforests of the sea because so much life depends upon them. Yet, compared to the deep ocean, reefs exist in relatively shallow, sunlit waters. Below them, the darkness continues descending for miles, and pressure increases constantly. At the deepest ocean trenches, pressure becomes almost unimaginable, more than 1,000 times greater than atmospheric pressure at sea level. Conditions so extreme that ordinary submarines would collapse instantly. And yet, certain life forms still survive there. Tiny organisms living under conditions once thought impossible. Perhaps this is part of what makes the ocean so endlessly fascinating. It reminds humanity how little we truly know. Modern maps may outline coastlines and continents, yet vast parts of Earth still remain hidden beneath water. There are underwater mountain ranges longer than any on land, volcanoes erupting unseen beneath the sea, canyons deeper than the Grand Canyon, lakes existing beneath the ocean itself and hidden beneath layers of sediment, the remains of ancient worlds, shipwrecks resting silently in darkness, cities once flooded by rising seas, artifacts untouched for centuries beneath cold water. The ocean preserves memory differently than land. Things disappear into it and sometimes remain hidden for generations. Storms especially reveal the power of the sea. A calm ocean can transform rapidly under changing weather. Wind builds waves, clouds darken, the horizon vanishes behind rain. In powerful storms, waves can rise higher than buildings. Ships are lifted and dropped repeatedly across moving mountains of water. Lightning flashes across black skies. Thunder echoes endlessly over open seas. Even modern vessels respect the danger of powerful oceans because, despite technology, nature remains larger, and perhaps that balance between beauty and danger is part of what gives the ocean its emotional power. It can feel peaceful, yet overwhelming, gentle, yet unstoppable, familiar from shorelines, yet profoundly alien in its depths. And tonight, as waves continue moving quietly across the surface of the earth, the ocean drifts onward through darkness, ancient currents circling slowly around the planet, moonlight reflecting across endless water, whales singing beneath the deep, bioluminescent creatures glowing softly below black waves, and far beneath it all, the hidden world of the deep sea continues silently through the night. Long before human beings understood the true scale of the oceans, people imagined what might exist beneath the waves. Ancient myths from cultures around the world often described the sea as mysterious, dangerous, and alive with unseen forces. Gigantic serpents, lost islands, sea gods controlling storms, creatures rising from darkness beneath ships, because for most of history, the ocean represented one of the last truly unknown places on Earth. Even coastlines could feel unpredictable. Fog could appear suddenly and erase the horizon. Currents pulled ships away from land. Storms formed with terrifying speed. And beneath the surface, the sea concealed everything. Unlike mountains or forests, the ocean hides its depths completely. A person standing beside the sea cannot see the vast landscapes beneath it. The underwater cliffs, the trenches, the volcanic ridges, the drifting creatures in darkness. The hidden world remains invisible beneath moving water. Perhaps that invisibility is part of why the ocean continues capturing human imagination so strongly. It feels endless because much of it cannot be seen. Even now, modern sonar and deep-sea technology have mapped only portions of the seafloor in high detail. Large regions remain poorly understood, and every year, scientists still discover new marine species. Some appear almost unreal. Transparent octopuses, fish with glowing teeth, creatures shaped like ribbons, leaves, or floating glass. Life in the deep sea evolved under conditions so different from surface environments that many organisms seem almost dreamlike. In the deepest waters, food is extremely limited, so survival often depends upon patience, slow movement, energy conservation. Some deep-sea creatures may spend long periods barely moving at all, waiting quietly in darkness. And because there is no sunlight, many animals rely more heavily on senses other than vision. Some detect vibrations, others sense electrical signals. Certain sharks can even detect tiny electrical impulses produced by living organisms nearby, allowing them to hunt in dark or cloudy water. The ocean is filled constantly with movement. Humans rarely notice. Tiny plankton drifting with currents, fish migrating enormous distances, whales crossing entire oceans seasonally, sea turtles returning to beaches where they were born decades earlier. Some migrations remain astonishing even to modern scientists. Arctic terns, though birds rather than sea creatures, migrate across enormous ocean distances each year between polar regions. Certain eels travel thousands of miles through the Atlantic Ocean to reproduce, and humpback whales may journey across entire oceans between feeding and breeding grounds. The ocean connects life across immense distances. Currents themselves behave almost like rivers within the sea. The Gulf Stream, for example, moves warm water across the Atlantic Ocean and influences weather patterns far away. Without major ocean currents, Earth's climate would be dramatically different. The ocean absorbs heat, redistributes energy, and shapes weather systems across the planet. In many ways, the oceans help stabilize life on Earth itself, and yet, despite their importance, the oceans often feel emotionally distant to people living inland, until perhaps they finally stand beside one and hear the waves. There is something strangely timeless about the sound of the ocean. The rhythm never truly stops, wave after wave arriving continuously, day and night, year after year. Thousands of years ago, people heard these same sounds beside ancient coastlines, Roman sailors, Polynesian navigators, Chinese fishermen, Viking explorers, children playing beside shores now long changed by time. The ocean outlasts civilizations. Empires rise and disappear beside it. Ports become ruins. Ships sink. Generations pass. Yet the tides continue returning quietly to shore. This sense of continuity often gives the sea an almost meditative quality. Watching waves for long periods can soften awareness of time. The repetitive motion calms the human brain, perhaps because natural rhythms existed long before modern schedules and constant stimulation. Rainfall, wind, firelight, ocean waves. These repeating patterns once surrounded humanity continuously, and many people still feel instinctively relaxed by them. At night especially, the ocean can feel profoundly different from daytime. During daylight, water reflects sunlight brightly. Boats move across the surface. Birds circle overhead. But at night, the sea becomes darker, quieter, and more mysterious. Moonlight creates silver pathways across black water. Distant waves fade into shadow. Fog drifts low across the surface, and beyond the reach of cities, the stars above the ocean become almost overwhelming in number. Ancient sailors often depended on those stars completely. Before modern navigation systems, the sky served as map, compass, and clock. Navigators memorized constellations carefully. The North Star guided direction, moon phases marked time. Cloud cover could become frightening. because it erased celestial reference points. Imagine crossing a vast ocean in darkness with only wind, stars, and memory guiding the journey. The courage required for such voyages becomes difficult to imagine today. And despite all modern technology, the ocean still demands humility. Even enormous ships remain small compared to major storms. Hurricanes forming over warm oceans can contain astonishing amounts of energy, winds spinning across hundreds of miles, waves rising and crashing endlessly, lightning illuminating walls of cloud above black water. Nature on a scale almost beyond comprehension. Yet the ocean is not only dramatic, much of the time it is quiet. Open water often appears almost empty, but beneath the surface, life continues constantly. Tiny organisms drifting through sunlight near the top layers. Fish moving in coordinated schools like flowing silver clouds. Predators gliding silently through darker water below. Jellyfish pulsing gently with slow, rhythmic motion. Seagrasses swaying with currents. Octopuses changing color and texture within seconds. Even coral reefs, vibrant with life during the day, transform at night. Different creatures emerge after darkness falls. Nocturnal hunters leave hiding places. Bioluminescent organisms glow more visibly. The underwater world shifts according to cycles of light and darkness, just like life on land. And perhaps one of the strangest facts about the ocean is how much life exists within regions humans almost never see. The deep ocean is sometimes described as Earth's largest habitat, vast beyond ordinary human perception. Cold, dark, ancient, a hidden world beneath the world. And somewhere tonight, far below the surface, whales drift slowly through black water. Tiny creatures glow softly in darkness. Currents move silently between underwater mountains. Marine snow falls endlessly through the deep, while above, moonlight stretches across the quiet surface of the sleeping sea. Far beneath the surface of the ocean, below the regions where sunlight still flickers faintly through blue water, there exists a world almost entirely untouched by human presence, the abyss. A place so dark, so cold, and so immense that it can begin to feel less like part of Earth and more like another planet entirely. The temperature in much of the deep ocean remains only a few degrees above freezing, not because it is near ice, but because sunlight cannot warm those depths. The warmth of the sun fades quickly near the surface, And farther below, the sea becomes ancient cold. Pressure increases constantly. Darkness deepens. The familiar world disappears. And yet, life continues. Scientists once believed the deep ocean might be nearly empty, a barren underwater desert. But as exploration improved, humanity discovered something astonishing. The deep sea was filled with life, not crowded in the same way as tropical reefs or coastal waters, but alive in quieter, stranger, more patient ways. Creatures drifting slowly through blackness, animals glowing with blue-green light, organisms surviving near volcanic vents where superheated water rises from the earth itself, entire ecosystems hidden beneath miles of ocean. Some deep-sea fish possess enormous mouths lined with transparent teeth. Others have expandable stomachs, allowing them to swallow prey larger than themselves. Because meals may be rare in the abyss, when food appears, it cannot easily be wasted. Some creatures barely move at all, conserving energy in an environment where survival depends upon efficiency. And perhaps one of the strangest things about the deep sea is how quiet it can feel, not silent, but softened, muted by water. Sound travels differently beneath the ocean. Whale calls echo slowly through darkness. Ice cracks in polar regions. Volcanic activity rumbles faintly from the seafloor. Rain striking the ocean surface creates distant underwater noise. Even shrimp colonies produce crackling sounds beneath the water. The sea contains its own hidden acoustic world. And because light disappears in the deep ocean, many creatures evolved to create light themselves. Bioluminescence appears everywhere in the abyss. Tiny flashes drifting through darkness, pulses of blue light, glowing trails left behind moving animals. Some jellyfish illuminate like floating lanterns. Certain squid release clouds of glowing fluid. Other creatures produce rhythmic flashes to attract mates or communicate. The deep ocean sometimes resembles an underwater night sky, living stars drifting through black water. And perhaps nowhere does the ocean feel more mysterious than near hydrothermal vents. These strange environments were not discovered until the late 20th century, deep beneath the sea, near tectonic plate boundaries. The Earth's crust sometimes cracks open. Superheated mineral-rich water rises upward from below. Black clouds pour into the surrounding ocean. Towering vent chimneys form slowly over time, and around them, life flourishes, tube worms, blind shrimp, pale crabs, bacteria surviving through chemical energy instead of sunlight. Before these discoveries, many scientists believed complex ecosystems required sunlight to exist, but hydrothermal vents revealed something extraordinary. Life could survive in darkness using energy from the earth itself. This discovery changed how scientists think about life beyond Earth too. Because if organisms can survive deep beneath oceans in total darkness here, perhaps life might also exist beneath the frozen oceans of distant moons. Europa, orbiting Jupiter. Enceladus, orbiting Saturn. Worlds covered in ice, with hidden oceans below. The deep sea became not only a mystery of Earth, but a clue about the wider universe. And still, despite all modern technology, humans continue discovering new marine species every year. Some appear almost impossible, transparent sea cucumbers drifting above the sea floor, fish with glowing red organs, creatures resembling floating ribbons, octopuses moving like ghosts through darkness. And because the ocean is so large, many scientists believe countless species remain undiscovered, especially in the deepest regions. The ocean floor itself is also far more dramatic than many people imagine. Underwater mountain ranges stretch across enormous distances. Volcanoes rise from the seabed. Deep trenches cut through the Earth's crust. There are underwater waterfalls, submerged rivers, and lakes beneath the sea itself, formed by differences in salinity. The ocean hides entire landscapes beneath its surface, places no human eye naturally evolved to see. And despite the enormous scale of the oceans, life within them often depends upon incredibly tiny organisms. Plankton drifting near the surface form the foundation of many marine food chains. Some are microscopic, yet together they help support fish, whales, seabirds, and countless other forms of life. Certain plankton also produce a significant portion of Earth's oxygen, meaning every few breaths a person takes may partly come from organisms drifting quietly in the sea. The ocean supports life on Earth in ways many people rarely consider. It regulates climate, absorbs heat, shapes weather systems, moves nutrients around the globe, and influences rainfall far inland. The sea is deeply connected to life everywhere, even for people who never see it. And throughout history, humans have depended upon the oceans not only for food and travel, but for imagination. Stories of Atlantis, sea serpents, ghost ships lost in fog, mermaids, leviathans. Ancient cultures often filled the unknown waters with mythology because the sea itself already felt supernatural. Storms emerging suddenly from clear skies, massive waves appearing in darkness, creatures surfacing briefly before disappearing again beneath the water. Even today, the ocean continues producing moments that feel difficult to explain emotionally. A whale surfacing beside a silent boat at sunrise, bioluminescent waves glowing blue beneath moonlight, fog drifting across black water at night. The sudden realization of how deep the sea truly is beneath you. These experiences can create awe very quickly because the ocean reminds human beings of scale, of mystery, of how much still exists beyond ordinary understanding. And perhaps that is why so many people feel calmer beside the sea. The ocean makes human urgency seem smaller. Waves continue arriving regardless of schedules or worries. Tides rise and fall patiently. Currents drift through darkness beneath storms. The sea moves according to rhythms far older than civilization itself. And tonight, as cities sleep beside coastlines around the world, the oceans continue quietly onward, moonlight reflecting across dark water, whales crossing ancient migration routes, tiny glowing organisms drifting beneath waves, currents circling slowly through the deep, and far below the surface, within the cold, endless darkness of the abyss. The hidden world of the ocean continues breathing softly through the night. Although the oceans appear connected from the surface, they are divided into layers with very different conditions. Near the top is the epipelagic zone, sometimes called the sunlight zone. This is the region most familiar to humans. Sunlight penetrates the water here, allowing photosynthesis to occur. Phytoplankton drift through illuminated waters, converting sunlight into energy. Tiny fish gather near reefs and coastlines. Sea turtles surface for air. Large predators hunt through open blue water. Most marine life people recognize exist somewhere within this upper layer of the ocean. But below it, conditions begin changing rapidly. The mesopelagic zone, sometimes called the twilight zone, extends downward into dim blue darkness. Very little sunlight reaches this depth, not enough for photosynthesis. Animals living here often develop unusually large eyes to capture faint light from above. Many species migrate vertically every night. rising towards surface waters under darkness to feed, then descending again before sunrise to avoid predators. This migration happens across enormous portions of the ocean every single day. Scientists consider it the largest animal migration on Earth by total biomass. Trillions of organisms moving silently upward and downward through the sea. Below the twilight zone lies the bathypelagic zone, the midnight zone. Here, sunlight disappears completely. No dawn, no shadows, no blue sky above, only darkness. Pressure becomes extreme. Temperatures remain near freezing. And yet, life continues adapting. Fish in the midnight zone often possess soft, flexible bodies because rigid structures are difficult to maintain under such pressure. Some species lose scales entirely. Others evolve enormous mouths relative to body size because prey is rare. Anything edible becomes valuable. Many deep-sea animals also produce bioluminescence because vision still matters despite the darkness. Light becomes one of the few ways to attract prey, identify mates, or confuse predators. Certain dragonfish possess organs beneath their eyes, producing red light. Most deep-sea creatures cannot detect red wavelengths, meaning the fish can illuminate prey without revealing itself. Some squid produce glowing defensive clouds. Others flash patterns across their bodies, almost like underwater signals. Bioluminescence evolved independently many times throughout marine history, which suggests it provides major survival advantages in deep water. And still deeper below the midnight zone, the abyssal plain begins. One of the least familiar environments on Earth. Flat regions of seafloor stretching across enormous distances. Cold, dark, covered with fine sediment slowly accumulating over millions of years. Marine snow falls continuously here. Microscopic shells, organic debris, dead plankton, dust particles. A slow, endless snowfall descending through black water. Some abyssal creatures spend their entire lives in these conditions. Sea cucumbers drifting slowly above sediment. Tripod fish balancing motionless on elongated fins. Tiny scavengers feeding on whatever reaches the bottom. Life becomes slower in the abyss. Energy conservation becomes essential. And deeper still, the Hadal zone begins inside ocean trenches. These trenches form where tectonic plates collide and one plate descends beneath another. The Mariana Trench is the deepest known example. At its deepest point, Challenger, deep, pressure exceeds 1,000 atmospheres. Enough pressure to crush most human-made equipment. Yet organisms still survive there. Certain amphipods, tiny crustaceans resembling shrimp, live within trench environments. Microbial ecosystems survive within sediments. Even at the deepest known parts of Earth's oceans, life persists. The seafloor itself is constantly changing. Tectonic plates move slowly beneath the ocean. New crust forms at mid-ocean ridges where magma rises upward. Elsewhere, ocean crust sinks back into the earth through subduction zones. Most volcanic activity on Earth actually occurs underwater, but because humans rarely witness it directly, people often forget the seafloor is geologically active. Entire mountain ranges exist beneath the ocean. The mid-Atlantic ridge alone stretches for thousands of miles, longer than many continental mountain systems. Hydrothermal vents often form near these tectonic regions. Superheated water, rich in dissolved minerals, erupts into freezing seawater. Temperatures near vent openings can exceed 700 degrees Fahrenheit. Yet nearby organisms survive because the surrounding ocean cools rapidly. Tube worms near vents possess no mouths or digestive systems. Instead, they rely on symbiotic bacteria living inside their bodies. These bacteria convert vent chemicals into usable energy through chemosynthesis, not photosynthesis. Chemosynthesis, meaning the entire ecosystem functions independently of sunlight. This discovery dramatically changed scientific understanding of how life can survive. It suggested ecosystems might exist anywhere. Liquid water and chemical energy are present, even far beyond Earth. The oceans also contain enormous carbon storage systems. Cold, deep waters absorb carbon dioxide from the atmosphere. Marine organisms help transport carbon downward when they die or produce waste. Over geological timescales, the ocean plays a major role in regulating Earth's climate. Without oceans redistributing heat and storing carbon, global temperatures would fluctuate much more severely. Ocean currents also influence weather worldwide. El Niño events in the Pacific Ocean can alter rainfall patterns across entire continents. Warm ocean water fuels hurricanes and typhoons. Sea surface temperatures affect atmospheric circulation. The oceans are deeply connected to planetary systems humans experience every day. Even people living far inland depend indirectly on ocean stability. And despite modern technology, Large portions of the seafloor remain poorly mapped. Detailed maps of Mars exist for some regions, more accurate than maps of Earth's deep oceans, because mapping underwater terrain is extremely difficult. Satellites cannot directly see through deep water. Researchers rely heavily on sonar systems mounted on ships and submersibles. Exploration remains slow and expensive. Some deep-sea expeditions require years of planning, specialized pressure-resistant vehicles, remote-operated robots, fiber optic communication systems. Even then, humans only observe tiny portions of the deep ocean at a time. The scale is simply too large, and the deeper researchers explore, the stranger discoveries sometimes become: fish with transparent heads, octopuses living near thermal vents, giant siphonophores stretching longer than blue whales, bacteria surviving inside ocean crust, ancient sharks inhabiting deep, cold waters for centuries. The Greenland shark, for example, may live for hundreds of years. Some individuals alive today could have been swimming through Arctic waters before modern industrial civilization fully developed. The ocean contains forms of time very different from human life. Slow currents, slow growth, long migrations, creatures surviving for centuries in darkness. And beneath all human activity above the surface, the sea continues operating according to ancient planetary rhythms. Tides pulled by the moon, currents driven by temperature and salinity, deep water sinking near polar regions and resurfacing elsewhere centuries later. A global circulation system moving slowly around the planet, sometimes called the ocean conveyor belt. Water completing journeys that may take hundreds or even thousands of years. An immense hidden circulation connecting the entire world ocean together beneath the surface. For most of human history, people understood only the surface of the oceans. Ships crossed the water. Fishermen worked near coastlines. Divers explored shallow reefs. But the deep sea itself remained inaccessible. The pressure was too extreme, the darkness too complete. The technology simply did not exist. Even by the 19th century, many scientists still believed life might not exist far below the surface because conditions seemed too hostile. Cold, dark, crushing. But gradually, evidence began changing that belief. Deep sea dredging expeditions brought strange organisms upward from depths previously thought empty. Starfish, crustaceans, worms, fish adapted for darkness. Life continued appearing farther below than expected. And in the 20th century, humanity finally began descending directly into the abyss. Early deep-sea submersibles were extremely limited. Small metal spheres lowered slowly into darkness by cables. Tiny windows. Minimal maneuverability. Immense risk. One of the most famous early deep-sea vessels was the bathyscaphe Trieste. In 1960, it carried Jacques Picard and Don Walsh to Challenger Deep within the Mariana Trench, nearly 7 miles beneath the ocean surface. The descent took hours. As they traveled downward, sunlight vanished completely. Outside the vessel, the ocean became black. Pressure increased continuously. The steel hull creaked under strain, and eventually they reached the sea floor, a place no human beings had ever seen before. Cold sediment stretching through darkness, tiny organisms moving slowly across the bottom, an alien landscape hidden beneath Earth all along. For decades afterward, very few humans returned to such depths. Deep ocean exploration remained extraordinarily difficult and expensive. Even modern submersibles face enormous engineering challenges. At extreme depths, water pressure pushes against every surface constantly. Acrylic windows several inches thick can flex slightly under compression. Metal components must resist collapse. Electronic systems require specialized protection. A small structural failure deep underwater can become catastrophic almost instantly. Because, unlike outer space, where pressure drops toward vacuum, the deep ocean crushes inward with tremendous force. And yet, despite these dangers, human curiosity continues driving exploration. Remotely operated vehicles now descend into trenches carrying cameras and robotic arms. Autonomous underwater drones map seafloor terrain. Scientists study ecosystems around vents, methane seeps, coral forests, and abyssal plains. Each expedition reveals more complexity, more biodiversity, more evidence that the deep ocean is not empty, but alive in ways humans are only beginning to understand. Some deep-sea coral colonies may be thousands of years old, growing extremely slowly in cold, dark water. Certain sponge communities also live for centuries. The deep ocean often operates on biological timescales much slower than surface ecosystems. Growth is slower. Movement slower. Metabolism slower. Life adapts to scarcity and stability. Near the surface, Storms constantly reshape conditions. Temperatures fluctuate. Sunlight changes hourly. But in much of the deep sea, conditions remain relatively stable for long periods. Darkness persists continuously. Cold remains constant. And because food is limited, many organisms evolved highly efficient survival strategies. Some predators conserve energy by barely moving until prey approaches. Others drift passively with currents. Scavengers descend rapidly whenever large carcasses reach the seafloor. When whales die, their bodies sometimes sink into the abyss, creating what scientists call whale falls. These massive carcasses become temporary ecosystems supporting deep-sea organisms for years. Sharks, hagfish, worms, crabs, bacteria, entire communities feeding gradually on a single fallen whale. Even in death, large marine animals continue supporting ocean life. The oceans are deeply interconnected systems. Nutrients cycle continuously between surface and depth. Tiny plankton near sunlight zones help sustain food chains extending miles downward. Whales transport nutrients vertically through feeding and migration. Currents redistribute heat and minerals globally. Everything remains connected through movement. And movement defines the ocean in another important way too. Because the sea is never truly motionless. Even apparently calm water contains waves, currents, turbulence, and circulation beneath the surface. Some waves travel across entire oceans. Storm systems in one region can generate swells reaching distant coastlines days later. Tsunamis generated by underwater earthquakes may cross the Pacific Ocean at jetliner speeds. Below the surface, internal waves move slowly through layers of differing water density. Some underwater currents carve channels through sediment over geological timescales. The ocean behaves dynamically at every scale, from microscopic drifting plankton to planetary circulation systems. And despite modern satellites and instruments, many ocean processes remain difficult to predict precisely. The sea remains too large, too complex, and too interconnected. Climate scientists continue studying how warming temperatures affect ocean currents, sea ice, coral reefs, and deep water circulation. Marine biologists continue discovering new species. Geologists continue mapping underwater volcanoes and tectonic systems. There is still much humanity does not fully understand about the oceans, perhaps because the oceans themselves resist simplification They are not merely scenery surrounding continents. They are active planetary systems shaping climate, chemistry, weather, evolution, and life itself. Even the oxygen in the atmosphere remains connected partly to marine ecosystems. The ocean influences nearly everything on Earth. And still, for most people, the sea is experienced only from the surface. Waves at shorelines, boats crossing bays, moonlight reflecting across water. Very few humans will ever descend into the deep ocean directly. The abyss remains distant from ordinary life, a hidden world beneath the visible one. And perhaps that distance contributes to the emotional feeling many people experience around the sea. A sense of mystery, of scale, of encountering something ancient and only partially understood. Because beneath every coastline, beneath every calm horizon, beneath every wave reflecting sunlight or moonlight, the deep ocean continues silently downward, layer after layer, cold water descending into darkness, currents moving slowly through trenches, bioluminescent creatures drifting unseen, ancient volcanic systems reshaping the seafloor, the hidden world of the abyss continuing quietly beneath the surface of the earth. One of the most unusual aspects of the ocean is that humans depend heavily upon it while rarely thinking about it directly. The ocean regulates temperature across the planet, produces a large portion of atmospheric oxygen through marine photosynthetic organisms, supports fisheries feeding hundreds of millions of people, drives weather systems, absorbs enormous amounts of solar heat, and stores vast quantities of carbon. Without oceans, Earth would be almost unrecognizable. Many coastal climates would become far more extreme. Rainfall patterns would shift dramatically. Temperatures would fluctuate more violently between seasons. Ocean circulation acts almost like part of the planet's circulatory system. Warm water moves away from equatorial regions. Cold, dense water sinks near polar areas. Deep currents travel slowly across the globe over long timescales. Some water sinking in the North Atlantic may not return to the surface for hundreds of years, meaning parts of the ocean contain water that has remained deep below since before modern nations even existed. The ocean preserves time differently, not only biologically, but physically. Deep waters move slowly. Sediments accumulate gradually. Certain seafloor regions remain relatively undisturbed for immense periods. This is partly why scientists study ocean sediments so carefully. Layers of microscopic shells, volcanic ash, and organic material build up over millions of years, almost like pages in a geological archive. By examining sediment cores, researchers can reconstruct ancient climates, ice ages, mass extinctions, changes in ocean chemistry, volcanic eruptions, even subtle shifts in atmospheric composition. The deep ocean remembers planetary history in physical form, and sometimes the sea preserves human history as well. Thousands of shipwrecks rest beneath the oceans, ancient merchant vessels, warships, submarines, cargo ships, entire pieces of human civilization lying silently beneath water. Some remain remarkably preserved because cold temperatures and low oxygen slow decomposition. Wood, ceramics, metal, even personal belongings survive for centuries in certain conditions. The Titanic, resting in the North Atlantic over 12,000 feet below the surface, became one of the most famous examples. When explorers first reached the wreck, many described the experience as emotionally overwhelming. A massive ship sitting silently in darkness, frozen in time beneath miles of water, marine organisms slowly covering railings and walls, the ocean gradually reclaiming it, and countless other wrecks remain undiscovered. Because the oceans are simply too vast. Even with modern sonar, searching large seafloor areas can take enormous effort. A single missing aircraft or ship may disappear into regions deeper and larger than entire mountain ranges. The sea conceals things extremely well. This is one reason ocean exploration often feels closer to space exploration than ordinary travel. Humans entering environments fundamentally hostile to unprotected life, carrying artificial pressure systems, oxygen, lights, and communication equipment into darkness. Submersibles descending slowly through black water resembles spacecraft entering another world. Outside the vessel, conditions remain lethal, and yet curiosity continues pulling people downward. Perhaps because the ocean represents one of the few remaining frontiers on Earth. A place where discovery still feels possible. New species. Unknown geological formations. Unmapped trenches. Ancient ecosystems. There are regions of the ocean floor no human eyes have ever directly seen, and likely many that will remain unseen for generations. The scale alone makes complete exploration nearly impossible. The Pacific Ocean covers more than 60 million square miles. The average depth of the oceans overall exceeds 2 miles, and certain trenches descend far deeper. If all continental land were leveled flat into the oceans, Earth would still remain covered entirely by water. The sea dominates the physical surface of the planet. Even Earth's tallest mountains have underwater equivalents. Mauna Kea in Hawaii, measured from its underwater base rather than sea level, is actually taller than Mount Everest. But because most of it remains hidden beneath the Pacific Ocean, few people think of it that way. The oceans conceal scale. Entire volcanic systems operate beneath the water constantly. Most volcanic activity on Earth occurs underwater. New seafloor forms continuously at spreading ridges. Elsewhere, tectonic plates descend back into the mantle beneath trenches. Earth's crust itself is recycled partly through oceanic processes. Hydrothermal vents deposit minerals around the seafloor. Submarine landslides reshape underwater terrain. Earthquakes beneath the ocean generate tsunamis capable of crossing entire oceans. The sea is not passive. It is geologically active on a planetary scale. And life evolved alongside these systems for billions of years. Some of the earliest known ecosystems likely developed in ancient oceans long before plants or animals existed on land. Single-celled organisms drifted through primitive seas beneath unfamiliar skies. Over immense stretches of time, evolution produced increasingly complex forms. Fish appeared, then marine reptiles, then mammals returned to the sea after evolving on land. Whales themselves descended from terrestrial ancestors. Ancient hoofed mammals gradually adapted back toward aquatic life over millions of years. Their nostrils migrated upward, becoming blowholes. Limbs transformed into flippers. Bodies streamlined for efficient swimming. The ocean reshaped them completely. And today, whales remain among the largest animals Earth has ever produced. Blue whales can weigh over 100 tons. Their hearts alone may weigh as much as a small car. Their low-frequency calls travel vast distances underwater. Entire lives unfolding across migration routes thousands of miles long. And despite their enormous size, they move through a world largely hidden from human observation. Most whale behavior occurs beneath the surface, in darkness, in depth, far from shore. Much of the ocean's life remains similarly unseen. Giant squid may spend most of their existence deep underwater. Colossal squid inhabit Antarctic depths humans rarely access. Deep pelagic fish drift through open oceans where almost no cameras observe them. Even species already known to science often remain poorly understood because direct observation is so difficult. The sea reveals only fragments of itself, and perhaps this contributes to its psychological effect on humans. The ocean feels endless, partly because it exceeds ordinary perception. Standing beside the sea, a person sees only the surface. The deeper world remains hidden. Unseen currents, hidden mountains, ancient trenches, creatures moving through darkness beneath the waves. There is always more below. And at night, this feeling intensifies. Moonlight reflects softly across black water. The horizon fades into darkness. Waves continue arriving slowly at shore. Somewhere far offshore, whales move silently beneath the surface. Bioluminescent organisms drift through cold currents. Deep sea fish glide through darkness where sunlight has never reached. Marine snow continues falling gently toward the abyss. And below it all, the ancient seafloor stretches endlessly through the hidden depths of the sleeping ocean. The ocean also changes dramatically depending on location. Tropical waters near the equator differ enormously from polar seas near the Arctic and Antarctica. Some regions remain warm and bright year-round. Others spend months beneath darkness and ice. Coral reefs flourish in shallow, sunlit tropical waters where temperatures remain relatively stable. These reefs support some of the highest biodiversity anywhere on Earth. Fish of countless colors move between branching coral structures. Sea turtles glide slowly above reefs. Octopuses hide within rocks and crevices. Tiny, cleaner fish remove parasites from larger species. Entire ecosystems exist within relatively small regions of reef, yet coral itself is fragile. Corals are living animals closely connected to microscopic algae living within their tissues. These algae help provide energy through photosynthesis, but when ocean temperatures rise too much, this relationship becomes stressed. Corals may expel the algae, causing coral bleaching. Large reef systems around the world have experienced major bleaching events in recent decades. Some reefs recover, others struggle. The oceans constantly respond to changes in climate and chemistry. And because marine systems are interconnected, changes in one region can influence ecosystems elsewhere. Near polar regions, the oceans feel entirely different. The Arctic Ocean and Southern Ocean surrounding Antarctica contain some of the coldest marine environments on Earth. Sea ice expands and contracts seasonally. Massive icebergs drift slowly through dark water. Certain whales migrate enormous distances to feed in these nutrient-rich regions during summer months. Krill, tiny shrimp-like animals, form enormous swarms supporting whales, seals, penguins, seabirds, and fish. Despite the cold, polar oceans support surprisingly productive ecosystems, but life there requires extreme adaptation. Some fish produce antifreeze proteins, preventing ice crystals from forming in their blood. Seals develop thick, insulating layers of fat. Penguins gather together for warmth during brutal Antarctic winters. The ocean creates environments ranging from tropical reefs filled with sunlight to frozen seas beneath months of darkness. And between these extremes lie vast open regions called the pelagic ocean. The open ocean contains relatively few physical landmarks. No trees, no mountains visible above the surface, only water stretching outward in every direction. For marine animals, navigation across such enormous distances remains remarkable. Sea turtles return to nesting beaches with extraordinary accuracy. Salmon migrate from oceans back into the exact rivers where they hatched. Certain sharks cross entire ocean basins. Scientists believe many marine species use combinations of magnetic fields, currents, chemical signals, temperature gradients, and celestial cues to navigate. The oceans contain invisible patterns humans barely perceive, and while some animals migrate across open water, others remain attached closely to the seafloor. Deep sea coral forests grow slowly in darkness. Glass sponges filter nutrients from surrounding water. Crabs patrol hydrothermal vent systems. Certain fish rest motionless above sediment waiting for prey. Even the abyss contains ecological structure, not emptiness, but slower ecosystems operating under different rules. The deep ocean also plays an important role in Earth's carbon cycle. When marine organisms die, some carbon within their bodies sinks toward the seafloor over long periods. This process helps remove carbon from surface systems. Tiny plankton near the ocean surface therefore influence global climate indirectly. The biological activity of microscopic organisms affects planetary chemistry. And yet, most people never think about plankton at all. The ocean contains countless examples like this, processes essential to life happening continuously beyond ordinary human awareness. Currents moving heat around the globe, microorganisms producing oxygen, deep waters storing carbon, whales redistributing nutrients, storm systems, gathering energy from warm seas. The ocean functions as one of Earth's central life support systems, and still, much of it remains unexplored. Some seamounts, underwater mountains rising from the seafloor, support unique ecosystems isolated from surrounding regions. Others contain species found nowhere else. Submarine canyons channel nutrients into deeper waters. Methane seeps release chemicals supporting unusual biological communities. Scientists continue discovering entirely new habitats, and technology continues improving ocean exploration slowly. Modern remotely operated vehicles can descend miles beneath the surface, carrying high-definition cameras. Autonomous underwater drones map terrain independently. Acoustic monitoring systems record whale calls across vast distances. Satellites track surface temperatures and currents from orbit. Yet, despite these advances, the ocean still resists complete understanding. Conditions are harsh, distances enormous, depths extreme, and the sea is constantly moving. Even observing one region consistently can become difficult. Storms interfere. Equipment fails under pressure. Currents shift. Visibility disappears. The ocean remains dynamic and unpredictable. This unpredictability shapes marine life itself. Fish schools move constantly. Predators follow shifting food sources. Storms redistribute nutrients. Seasonal currents alter migration routes. Nothing remains perfectly fixed. The sea rewards adaptation. And perhaps this constant movement contributes to the psychological feeling people often experience near the ocean. Watching waves can create awareness of impermanence. No two waves are identical. Patterns repeat, yet continuously change. Water rises and falls. Tides advance and retreat. Storms form and dissipate. The sea never truly stops moving. Ancient philosophers across many cultures noticed this. Some compared human thought itself to water, changing constantly, difficult to hold still, capable of calmness or turbulence. And unlike many environments shaped heavily by human activity, the open ocean still feels larger than civilization. Ships crossing vast seas remain small against storms and distance. A lone vessel at night, surrounded by black water, can feel isolated in a way modern life rarely allows. The horizon disappears. The sky expands. Human concerns shrink temporarily against the scale of the sea. Perhaps this is why oceans appear so frequently in meditation. Sleep sounds, and reflective experiences. The rhythms feel older than human systems. Waves continue regardless of schedules or technology. Currents move slowly beneath political borders. Whales migrate through waters crossed by countless civilizations before them. The sea connects present time with something far older, and tonight, far from shorelines and sleeping cities, the oceans continue their endless movement around the planet. Cold, deep currents circulating silently beneath warmer surface waters, bioluminescent organisms glowing softly in darkness, whales navigating ancient migration paths beneath moonlit seas, storms gathering energy across warm tropical waters, ice drifting slowly near the poles, marine snow falling gently toward the abyss, while the hidden world beneath the surface continues quietly onward through the long, dark night of the earth. And perhaps one of the most remarkable things about the ocean is that despite all human technology, it still remains partly unknowable. Satellites orbit above the earth. Ships cross nearly every major sea. Submarines descend into trenches. Scientists deploy robotic explorers miles beneath the surface. Yet, the ocean continues hiding vast portions of itself in darkness. Entire ecosystems remain poorly studied. New species continue appearing. Ancient currents still move through regions humans rarely observe directly. The sea does not reveal itself quickly. It exists on scales larger than ordinary human experience. Larger than cities, larger than nations, older than civilization itself. For billions of years, waves have moved across the surface of the earth, long before roads, before language, before memory. Ancient tides rose and fell beneath unfamiliar skies. Storms crossed empty oceans before human beings ever watched them. Whales migrated through darkness before the first cities were built. The sea remembers worlds humans never knew. And perhaps this immense age contributes to the feeling many people experience beside the ocean. A feeling difficult to fully explain. Part calmness, part awe, part loneliness. Standing beside the sea often changes a person's awareness of time. Waves arrive continuously, not rushed, not delayed, only steady, one after another. The ocean does not hurry. Currents move at their own pace. Storms gather slowly over warm water. Tides respond quietly to the pull of the moon. Deep circulation systems take centuries to complete their paths around the globe. The sea operates according to rhythms far older than human schedules. And somewhere tonight, far beyond shorelines and sleeping cities, the open ocean stretches endlessly beneath the stars, cold water drifting slowly through darkness, whales crossing ancient migration routes, tiny bioluminescent organisms glowing softly beneath black waves, deep currents moving silently through trenches unseen by human eyes, marine snow continuing its endless descent toward the abyss. A hidden world beneath the visible one, quiet, ancient, vast beyond ordinary thought. Perhaps a lone wave breaks gently somewhere along a distant shore, moonlight reflecting silver across wet sand, wind moving softly over dark water, clouds drifting slowly across the night sky, and beneath the surface, the deep ocean continues calmly onward, unhurried, layer after layer descending into darkness, the midnight zone, the abyssal plains, the ancient trenches of the earth, silent volcanic mountains hidden beneath miles of sea, creatures drifting slowly where sunlight has never reached, the sleeping world above, barely aware of the immense depths below. And gradually, the horizon softens, the stars blur faintly above the water, waves continue their slow, repeating rhythm, rising, falling, rising again, the ocean breathing quietly through the night, endless, patient, ancient, until only darkness, water, and the gentle drifting motion of the sea remain.